Sure. Okay, all right, so let's begin. Okay, so before we dive into other topic today, we have some leftover SQL SQL functions or operators that has to do with characters and strings, okay? And those, there are plenty out there. So I think that two available dictionary that you would reference as needed, either for your homework or in your future, I recommend W3 School. It's just an easy access place for like a SQL wiki or Microsoft. All right. And a couple more that we need to cover. So one of them has to do with pattern matching. So you shouldn't be unfamiliar with regular expression. What it is using ASCII characters available, and it has certain like pattern ways to match whether a text or a word or a sentence is what your pattern is supposed to match it to be. Okay, so the syntax would be if you look at the very end on the right hand side, where email expression some such as Gmail, whatever.com. Now, the exact syntax is a profound dictionary that we are not going to have to recite or memorize at all, but just know that it exists out there. And is used a lot of time when you have form validations. And so, such as email, you use regular express to check what domain or that followed by a .com or gov, etc., or making sure that it has an at sign, for example. Concatenate. Okay, so the concatenate function is short for concat, concact in string. So it is a method or a function in SQL that you can use in your select query to easily combine columns, especially when both columns are string. Okay, you can really easily, as you can see in the example, contacting first name and last name so that it would be a full name display, okay? Or if you want to store city, state, zip in separate columns and but displayed it in a full address, you can also use concatenate with that. And it's as simple as just putting down all the attributes that you want and separate them by comma. Okay, subquery in select. So last week, we really went quickly on this keyword in. Okay, so when you use in, and especially when you're using an aware clause, it the return value, say if it was returning just one attributes, one columns, there will be multiple rows, right? So all the rows of that one column became a list of selections that your where clause evaluation can match to, right? So it became sort of like a or statement in a graceful way. Now, you can also have the subquery of select statement, not just after in, but also in this case, in the select line of select clause within a select statement. Okay, so for example, in here, it's basically counting, the employee it's basically counting the orders that a sales employee has sold. Okay. And this what it does here is that uh it's basically trying to make sure that the count of this or account of the orders that is sold by the sales employees are attribute to one employee of all the sales. So basically, not all sales within the companies across employees, but each employee, how many total sales they make. Okay. So this is what it does here, and then using a select query. Now, if you look closely at the result, okay, the result display just as it's supposed to, right? Employee ID with the order sold. Now, if you look at the result and pay close attention, you would realize that as a flashback, it's basically doing, if we don't use this sort of a subquery of select count, the result versus the original select query outer loop, it's essentially as a flashback, you should know that it's doing similar to another aggregation method that we spoke about last week. Can you guys think of what I'm talking about? So it's now dividing the complete order sold by employee. Can I ring the bell that can you guys think of another what we have discussed last week about?
This is group by.
That's absolutely group by. Yes, it is correct. Group by. Right? So just quickly, if it was group by, okay, instead of having the select count, right, it would just be count star. Okay, and that is okay, right? We'll just have in the select first line to be count star. Now, what's different here would then be after the from employees e table, it will be group by, and in order to have group by, we always need to have select statement, select li the lines on select first line to balance with whatever you got in group by, right? So now, what happens in select line again will be the same with e.employee ID, e.first name, and as well as the count star, right? As count star as order sold, but we'll add a final line with group by. It will have e.employee ID, group by e.employee ID, as well as e.first name, because you always have to balance the two columns, the whatever column there is that are not aggregated attributes, right? So essentially, this query that's used in subquery is an equivalent way of doing group by. So you can have options when you are thinking about getting value by divisions of, certain attributes, counting the total counts of certain divided by the attributes this way instead of group by. Okay, cast and convert. Okay, so the convert and cast, the difference between convert and cast is just that cast in here in SQL means that you're changing how your uh, numbers are displayed. So you're changing the data type to the number. So you're trying to format it. So for example, if you want to change uh, a number that is in flow, for example, like has a lot of decimal and to just doubles with two decimal, you would use cast. Now, convert is when you want to uh, follow appropriate. For example, if you have 100, uh, but you initially had, for example, maybe from your code or whenever you're ingesting or inserting, you had originally with the data type being in string, such as the varchar, right? You may want to consider in order for you to benefit doing calculation and mathematics, you may want to convert that to integer, right? Because you cannot add string with string. So you cannot add varchar with varchar and then try to get a number out of it. If you add varchar to varchar, you would need to use concatenate, and the end result will still be the combination of the strings instead of the actual sum in mathematics, right? So you need to convert that, okay? Substring is getting a specific subparts of your text, your varchar data type. You can define where you want to start and end. All right, now Uppercase, lowercase, you will use upper, lower, okay? Or final init cap, meaning like the first letter being capital, right? These are some just kind of graceful functions that you could use, are pretty common as well. If you want to make sure that, when you display certain information such as names, that you appropriately have it in init cap, etc. Okay, coming back to just kind of final look again on the wildcard. All right, so we've talked about over here, there's an example. We're using like compared to a and whatever, right? So whatever start with capital A and followed by ampersand means that a and then followed by whatever character behind the a character, as long as the product name start with capital A. So Apple, uh, um, uh, Alabama, whatever, right? They all start with a capital and doesn't matter how many string afterwards. Now, using underscore, then is specific on the amount of character that you are allowing it to be a wildcard, right? So you will use like when you're comparing to underscore or ampersand, etc., right? You will use in if you're comparing to a subquery, a select statement, blah, blah, right? Or you can use in followed by a you can use in followed by parentheses with double with single quotes and comma separated, right? Now you will use regular expression, all right? And then this is not something that you need to recite. Again, just know that there's regular expression. When you're comparing regular expression, you will say name and then directly that evaluation function is reged, regular expression, right? And then followed by the patterns that you're matching it with. All right, there's still a lot more, okay? And as I mentioned, you can go back to the slide later on to find a dictionary on those two recommended websites. If you ever wonder whether or not there's a quick, easy function while you are doing some evaluation using string. All right, so let's come back to another topic today after we parked aside the string functions. Now, any questions on string functions? All right, let's park that aside and then let's start thinking about what we have covered a while ago, which is the different type of schema. Okay, so in relational database, if you recall, I mentioned that majority of time when we're talking about schema, we are referring to tables, right? Now, there's two other type of schema. There's two other type of schema. Okay. And if you remember, the second one after table is called a view. Okay. So a view in SQL is a virtual schema. Basically, visibly, it just look like a table. But it's based on the result set of a SQL statement, and namely select statement. Okay. So let's quickly jump over here on how you create a view. So create view and or replace view, right? If you decided that this is not the right result set, okay, you will use replace view if it already exists. Create view and give it a name, then you put as, okay, as. Then select blah blah, like a select query that you will normally do. Okay? So basically, the result, so as we know, the select statement will return a result set, right? And that's not what we initially had created a table. Normally, it's a result, and then but it's still displayed in the tabular format with columns and row, as we all know. So when you create a view followed by a select statement, create a view name and then as followed by a select statement, essentially what you're doing is that you're now storing that query. Okay. This is very important. You're storing that query, not the data. Okay. Storing that query as the structure of this view. Okay. digest it a little bit. You're now storing this select query almost like it's almost like you're saving this select query. Okay, but you're giving it as a file name called view. Almost think you can think of it that way. But the actual data or actual value, amount of data or whatever constituent actually doesn't really, it's not what you're actually saving. Okay, you're only saving the structure. Now, what would happen when you do that is that when you store, when you create a view, okay, you store the select statement. And as we see earlier here, it would allow easy access for you. Let's say if this is a join statement, or this will only have one inner join. Maybe it has one inner join, three other left join, or whatever. It just helps to speed up so that you don't need to always start from scratch writing a join statement or a complex select query. That's number one. Number two is that this creates views. This view, after you create it, the structure will be stored in the schema sections of your database. So every time you call this view, you will just kind of query it like select blah blah from table. It will be the same. You'll just be select blah blah from view. Now, it's always going to pull the latest bunch from the result set of this join table. So you don't have to worry. It's the as long as it's from the underlying table has been updated or it's going to be updated as well when you're calling or when you're querying against this view. All right. So the benefit of this view is that because it's not only storing the select complex select query, but also imagine this. You may, as a database administrator or developer, maybe one day you're working with data scientists or whatever, and they may want to have certain data set available for them quickly, but they don't necessarily ever have to work on deleting or any DML or DDL, right? And so they just want read-only access of the data. So it could be a good solution to separate and then so to provide views to these other read-only user, right? And so that it's giving the extra layer of protections of your actual underlying data, right? That's something that you should think of as a developer, like something always, okay, how do I give the minimal viable authority of data to other user and then based on their needs, right? So that is the second benefit. Okay. But it's always going to pull from the underlying querying and then to the underlying table. So you don't have to worry about the view is outdated or anything. It's just storing the structure, but the data will always be fresh. Now, however, some databases, and you will need to check by different brand basis that whether or not it's have a additional benefit, meaning query caching. So what query caching means is that if a view was last used not too long ago, they might park this view along with its constituent data in the memory so that they will be cached and along with the next time when it's query, looking for the delta meaning the differences between the most updated and this cached in the memory table in order to speed up returning result. Okay. But this is based on different brand. Not all the brand does that. I don't know if MySQL does that. I would say I would be kind of leaning towards they do. Okay, most of the known relational database does that these days to cache uh, the data from the last query in memory. Okay, so that is view. Okay, it's good read reading only virtual storage for a complex or often frequently used query. The third type is a temporary table. Okay, it is a temporary table. Now, the temporary table, namely, it is just nothing different from a table, if you think of it, but it's just that this table is often only created within a function or within a procedure to temporarily store subset or to store a result set of data, right? In order for that function, which we may be getting into learning later on today, so that we can have a local temporary table to store a result set. And then if we needed to use a loop to process each single row of that maybe uh, temporary table, we can, right? So the temporary table are normally stored for that purpose. It's nothing that different from a table, right? And temporary table is normally created in two different ways. And the first way is just as I described. When you have a function or a long procedure and you're doing slightly complex uh, querying, okay, or you have a if condition or whatnot store procedure, you want to store result set. You use a 10 table for that purpose, right? And just like kind of how you can imagine that maybe we are uh, within, let's say within a for loop, right? And a for loop within a function, let's say in Python or Java. Okay, you have a function, within function, there's a for loop. Right outside of for loop, there's a, let's say, array list. Okay. And that array list is meant for you to store data structure of objects, right? And then you use the for loop to process it or whatever until it's done. Now, once it's done, kicking out a for loop, and then when you're returning that, I guess that array out of the function, that array within the function will then be deleted, right? As long after it returned back to your main code, that function itself will be deleted. So this is one examples of usage of temporary table. The other usage that similar concept, but we don't really consider it as a temporary table, but a fundamental is the subquery, right? When you are building these subquery right here that we just went about, talk about here, right? A select statement within a select statement, right? It's like nested loop, if you want to say, or nested query, they are essentially also store gracefully using a similar method. And you can imagine this is just like they're storing a temporary table. Okay. All right. So that's the three type of schema concept. Any questions before we moved on? Okay. So let's come back to another familiar faces. Okay. Primary keys, foreign keys, or just namely integrity and constraints. Okay. Just refreshing your ideas a little bit. The last time we ever, or last couple times we ever mention and talk about constraints and integrity, uh, it's probably having to do with the primary and foreign keys when we talk about constraint and integrity, as well as when we may have mentioned about the transaction feature or characteristic or asset. Those are all the places that we talk about and we brought up constraints and integrity, right? And then one other place that is slightly more remote, but is also related, still, somewhat related to integrity and SQL constraint is when you're normalizing, right? All these things are when we are mentioning integrity. and constraint you think of, right? Primary keys, foreign keys, relationship, transactions, normalizations. Now, as I mentioned before, firstly, let's look at the keys. The primary keys and foreign keys. Remember when I introduced you these keys concept, especially the primary key and FK foreign keys. Remember, I have told you that from day one, you can create a database however you want, as long as you can compile it and then the database understand it, and you go ahead and create a table. It doesn't need to be whatever normalized. It doesn't need to have any relationship. Now, starting at the point when you start thinking about redesigning or making your database more normalized or defining relationship between your database, that's when you start thinking about the primary keys and foreign keys, when you're thinking about these actions, because these actions come with benefits, right? When you're starting to define relationships, namely the primary keys and foreign keys, right? It comes with benefits, right? The benefits is that not only now they have relationship that we know between the two table, and fast forward, it could help on the future normalizations that you want to add, or you want to initially start with making sure that it's quite normalized to the second normal form, right? So there's benefit that we already know by normalizing your database design. But also building that relationship has its own benefit. And let's review what those benefits are. So, for example, you can have a column with a unique constraint already, right? A column, when you're creating a table, you can say unique always. You can make sure the attribute is unique, right? You can always already create, you don't need to have a primary key constraint, or you don't need to create primary key on that column in order to make that a official ID. But if today you decided that having a primary key is beneficial because you want to use other tables and referencing it using foreign keys, then here are the benefits, right? The system will ensure that when you create a primary key, it would have to always be unique. So that means if for some reason your code, when you're adding a random number and or random string of this primary keys, if it had duplicates, it will throw an error, right? Second, not null. Primary key cannot be null, right? So if for some reason in your code there's a bug, and then somehow or whatever design that you have, there's a null on this primary key, it's going to throw an error, or it's going to have no action. It will let you know that there's these things that you need to follow, right? Similarly, foreign keys, right? It would make sure that when you're adding a reference from a child table to parent table, namely by adding foreign key, that foreign key value needs to already be having its existence as a primary key in the original table, in the parent table, right? So these are constraints. However, they're also benefit because now you're getting all these checks and balance for free from relational database, right? So constraint and constraint sometimes because you're implemented it, it became sort of checks and balance and sort of also its benefit. But in addition to these unique not null or making sure that primary keys has existed, right? It's also putting you onto hopefully a better track of understanding the relationship between different table, right? there are more to primary keys benefits, which we're going to cover just in a couple of slides down. But today, in addition to these constraints, we are going to also introduce you integrity. Okay, so namely, think about this. We've said that a foreign keys can only be created, right? On your foreign tape on your child table, you can only have a table referencing the parent table with the foreign keys when the primary keys already exist in the primary table, right? So for example, I am an Amazon customer. I place orders, right? So I am a customer. Therefore, in the customer table, I assume I have a representation of rows, and then I have a customer ID. And other non-ID attribute will be my name, my address, etc. My customer ID, say it's the primary key, and it's 1, 2, 3, 4. Now, all the orders that I have placed, let's say if I didn't place any order, fine. On the order table, there will likely not be any rows with the foreign key of customer ID from the customer table with 1, 2, 3, 4, right? Because if I haven't placed any order. If I did place one or many order, there will be one to multiple rows, right? To order table with foreign key customer ID 1, 2, 3, 4, right? And just to sum up, the customer and order table is one-to-many relationship, right? Using primary keys, using the foreign keys to combine to bond them together. And that foreign key, give me 1 second. Sorry about that. Sorry, groups. Let's just give me 3 minutes. Sorry, some emergency call. Okay, sorry, I'm back. Some distraction. All right, so we will be talking about what I mentioned, integrity, uh, today, referential integrity. Now, continuing with what I was saying with the example. So now we established that there's a customer table, order table that we are, referencing to. Now, what would happen if intentionally or unintentionally, me with the customer ID 1234 have been removed or is being attempted to be removed from the customer table, right? Think about it. We've talked about earlier that foreign keys need to can only exist and be added to the table, child table, if that ID already is a primary key and existed in the parent table, right? Now, what would happen if we're trying to remove that foreign key afterwards from the parent table? Okay, this is what we are going to go and then discover. All right, so two of the very common problem here. One, as I mentioned, if I, for some reason, with a customer ID and Amazon customer table, is being removed from the customer table, right? It's called delete. I mean, it's delete, undelete, right? The primary key is being deleted, right? This would be triggering some type of warning or awareness in the database because this action is obviously abnormal. So by default, what happens is that if these actions are being uh, executed, or when you're pressing the enter button, trying to delete the customer ID 1234 while there's already, foreign keys existed on order table, by default, MySQL will say this is not a lawful or this is not in compliance with integrity. So throwing you an error, nothing happened because they will error it out. Okay? So that is by default. The reason I will do that is so that the integrity of this reference will be intact because the foreign keys needed, one of its referential integrity and constraint is it needed to have the parent primary key. So that by default, it would make sense so that the database is going to throw an error, restrict you from actually commit to this action. However, there's two possible customizations that you can make to tell the database, should you, who is the owner of this database or table, want it to behave not by default, right? Two solution you can have, or two customization you can have. First one is what we called on-delete cascade. Okay, let's take a look how I will write that. Look at bottom over here. If you decided that you want your database after you have all these table created and you already have primary key and foreign keys, you're deciding, oh wait, I don't actually want the default behavior and I want to change the default behavior. So when my primary key is being deleted, even though there is a referencing foreign key in another table, I want it to do certain action. And there's two actions available or two behavior here available. One is called cascade. So if you look at the bottom here, the way you will write it is that you would alter the table. And if the foreign key doesn't exist, you will add the foreign keys, referencing table primary keys on delete. This is what you have to put on delete. It says that this on delete means that, okay, tell me what you want when the primary key get deleted. What you want to do. If you put cascade, that means that if the primary table, the primary key has been deleted, then you essentially want to customize the foreign table, the child table, to delete all the rows that has that foreign key. That is called on delete cascade. So basically, it follow what your primary key is doing. That's why it's called cascade. It's updating. Okay? Now, below here, the example here is if you didn't have a foreign keys, you could also, if you already have a foreign keys, obviously you can just alter table and update the foreign keys as well, right? You can do that. Now, second behavior you can set it customized to is called onDelete set null. Now, that onDelete set null would do is instead of updating accordingly to the primary key by deleting the entire row, you are just setting the null on each of those rows foreign key, that attribute only. Okay? You might come back and say that, okay, this is a little bit of not very super intuitive. Yes, that's why by default it would not happen. It would not have any actions, right? That's the behavior. Like by default, relational database would not have any change, and that's by default, and that's why it's more intuitional, right? But if you want to customize, there's two ways to customize it. One is if the primary key is deleted, then all the rows that has the foreign key would also be deleted. That's the cassette. The set null is that if the primary key is deleted, all the foreign keys will be set null, but the row will stay the same. Now you'll just have these orphan rows in the foreign table. And that may be the behavior intentionally or unintentionally, but that is at least available options that's out there for customization. Now, the other thing that you can change, and here are some more um, syntax, and then also the impacts on your databases itself, and then just kind of go through examples. But the other available scenario that I want to talk about. Yes, what is the question, Nathan?
Can you give me a quick uh, hello?
Sorry, Nathan?
Hello?
Yeah, I can hear you. What's up? Yes?
Professor, he said microphone is not working and he is typing in the chat.
Oh.
Wants a example of cascading, like if you could provide a simple example. He said he wants that.
What do you mean by sample? Like the examples are these are example code right here. On the left-hand side, there's a code, foreign key, and then you just that's how you will write it. But what do you mean by example? Well, here's the thing. I have to think of it just like you are because these are not example of that. It's that we're talking about customizing, and it's not necessarily a common use case to customize it because normally people want to adhere to the referential integrity so that they want the default behavior, right? So I can't I don't know if I can bring up like a random because I personally don't have experience customizing it because I don't think that's how I would design the behavior, right? So, why would I delete it? Maybe let's see. Mm, maybe okay, maybe a course and enrollment table, maybe like a course table and an enrollment table, right? And then maybe because there used to be a course, let's say CS336 on Tuesday, and there's already 18 people enrolled, or maybe there's only 12 people enrolled, so that the Department of Computer Science decided, okay, it's not enough people, we're just going to close it. That happened, I mean, in real life, to be honest with you. And maybe, I'm not saying that that's the right way to do it, and maybe whoever owns the enrollment database or whatever database in school decided that, okay, I'm going to delete the course from the course table, right? And the course table, course ID is being referenced and foreign key in the enrollment table, right? Right? And then maybe, the database developer for, the class enrollment has customized it. And so that basically if this class is deleted, also go ahead and delete all the enrollment to this class, right? So maybe they want to save space or whatever. They don't want to keep like the history of registration. Okay? But again, you see, I am hesitant to come up with example, not because I don't know what example, is that I don't want to confuse you with giving you an example and telling you that that is the right way to do things. You understand what I'm saying? Because nor in the normal common practice, you would just follow the default behavior. Okay? But here is the two common customization that the relational database also offer, whether or not is the right and the most best practice is up to the product, right? It's up to the person who owns the database, right? Or the stakeholder, right? So, if that makes sense. Okay. Now, we covered the one with deleting the primary keys. Now we are going over on the updates, right? Okay, so the updates, similar, right? Let's say for some reason, Amazon today, my primary key is 1234, my name's Sheng, and then last name Chen or whatever, and address, blah, blah. Now, they decided, for whatever reason, they are about to update my customer ID to 2345 instead of 1234 before. Now, if I never bought anything and placed any order, or I never browsed Amazon, whatever, we are probably going to assume that there's no row on order table, therefore no foreign keys that is using 1234 customer ID, right? That would be okay. Let's say if they're updating it or they're trying to delete it, they're updating to 2345, or they're just trying to delete me as the customer, right? Because I never place anything. That would be most likely okay, because by default, even by default, there's no record on order table, on the foreign table. So it will get deleted, fine. But let's say I am a frequent customer. I place numerous of order. So now on the order table, there's foreign IDs, foreign keys of 1234. Then what? Okay. By default, okay, let me see if there's okay. By default, if in this case, Amazon is trying to update 1234 to 2345, when I am a frequent customer so that my order table has me multiple times as a foreign key, then again, default behavior would give you an error and stop anything from taking place. So nothing would change. It would restrict you from making this update. That's the default behavior of MySQL and many relational database. That is so that it's adhering to referential integrity. Now, two customization available to consider. Again, on update cascade. Or on update set no. On update set no. Now, slightly different from the delete situation now. Okay, so the on update cascade, what would happen is if the primary keys is updated from 1234 to 2345, it is going to go to the foreign child table and update all the foreign keys from 1234 to 2345 as well. Now, that may not sound so bad, right? Again, I don't know if that is some behavior that you as the owner of the database or in the future, when you're the one that making that call decision, I don't know if that is the most best practice, but it is a available options on update cascade. On update set no, another customization option. You would instead of updating the foreign keys in your child table, you're setting them to null. So now that relationship is broken again, and these items, these rows on your child table essentially are orphaned. Now, it is a available customization and available behavior for you to go and customize that into. Does that make a lot of sense? Again, it will be to the beholder. Okay, I don't know if that is the best practice, but however, that option is there to consider. Right now, let's summarize what we have gotten so far. We talk about integrity. We talk about constraint. And when we talk about constraint and integrity, the first thing that comes to our mind is those best practices, normalizations, primary keys, foreign keys, relationships that these relational data model provide for us with pros and cons. Pros means that given these boundaries, given these constraints, we have to follow the relational database rules, but at the same time, we're giving some benefit for free, such as making sure a primary key is set to its rules, a foreign key set to its rules, and making sure that there is these constraint and default behavior when you have foreign and primary relationship, right? When you have these relationship bounded, right? So those are constraints and integrities that we are when we are talking about SQL. And there's always pros and cons. And you should know that when you added that, that's by design. The constraint give you a lot of rules, but it also give you these automations of checks and balance. Now, after talking about this primary keys and foreign keys constraint, there's another actual benefit that I talked about before briefly, and we are going to dive in slightly more today. Okay, so that is the index. But before we get to the last part of this slide, which is the index, let's review all the different keys here. We just went about primary keys cannot be null, cannot have duplicates. There's only one primary key in a table. Foreign keys can be multiple, but it needs to have its primary keys from the parent table existed already. And primary key and foreign key bound the relationship to table, and it needs to follow by default the referential integrity, as we just learned. Unless you go and customize it and set it otherwise. But in relational database, by default, there's all these constraints that make checks and boundary as the benefit, but you need to follow these constraints. Unique keys, I mentioned before, you don't necessarily need to have a primary keys to create a column or have a column to be unique. You can have it set to be by default unique when you're at creating that columns or when you're creating table and then writing that column. You just have to put unique in there so that that columns will throw an error if there is non-unique or duplicate value added to it. Candidate keys, actually, let's jump to combo keys, which we are familiar with. Combo keys are primary keys. It's just that the difference between combo keys and normal primary keys are that it is combined with multiple column, more than one columns, okay? And combine more than one column into making a primary key. So that's called a combo keys. Candidate keys. Keys means that any keys within the combo keys are candidate keys. Okay? Any keys individually or any subset of the combo key set. If you're thinking about set theories of math, any subset of the set, any subset of the set. So any column under combo keys are candidate keys. Now, slightly further, there are other candidate keys that is not part of the combo keys, meaning that if you just have a table that has so many, for example, you have a user table that have so many columns that can potentially be primary keys or part of the combo keys, but you have many options and then some of them that you just, you know, that didn't make the list to be a primary keys. They can still, as long as they have, this key-like integrity, they could be a candidate. So they are also part of the candidate keys. For example, emails, right? For example, phone numbers, or for example, phone number combination with birthdays. That could also be candidate keys. Or for example, zip code, birthday, last name. That could also be, but maybe not as strong as the one that you essentially end up picking, right? So that they just didn't make the list, but they are candidate keys. What are super keys? Let's come back to the set theories again in your math. Recall or Google, whatever, if you don't remember. What is a set? A set is one or many numbers or no number at all, okay? And then there are no duplicates in there, right? That is a set of numbers. Now, what is a superset? A superset of number is that with having the original set, adding another number, that became a superset. So for example, if a set, or imagine a combo key is 2 and 3, or a combo keys is first name and last name. Okay, that is the set, right? Using the set theory, that is the set. Super key will be 2 and 3 and 4, superset. So super keys will be first name, last name, zip code, for example. So you would absolutely need to have the set itself, which is the first name and last name, and add another one. That is superset. And in this SQL case, when we talk about keys, that is what a superset, a super key is. With whatever combo keys you got, primary key you got, adding another attribute to it, that became a superset of the key, and we call it super key. Okay? Finally, let's come back to index. All right. Anybody remember index, what they are? What is index in terms of relational database? What is index in terms of SQL database? Not just regular indexing. What is it? No. 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 Remember, there's no data structure in SQL. Nope. Tyler, it's close, but not really. Relation to the position, no. Indexing, actually, I'm gonna explain, and why don't we also scan this QR code for attendance right now? Okay. I'll jump back after you guys are done. Okay. Indexing. Okay. What indexing is that if you have a table or if you have multiple table in the database, right? And you have discovered that there's certain column or there are combinations of multiple columns that are often gets filter on, meaning that it's often using your where clause to evaluate with some values, or it's often used to join on with another table, or it's often getting queried on, meaning that it's often being selected and displayed in the first line of select query, which is the select clause, which is eventually getting displayed in your results. For these purposes, you want to index that column or columns as a combination of multiple column, in order for your query to run faster. Okay? That is what a index does. You essentially adding the index to a column. The reason that we put the index with the keys is we're following the similar concept of adding a key to column, right? A column itself can be unique. A column itself, without being a key, it can be a ID, right? It just doesn't have all these constraint and benefit that we talk about, like, all that. But in itself, there's nothing stopping you to store unique numbers, right? And using it just raw as ID. But you're adding these key to the column, right? Using outer query, adding key to this column as foreign keys or as primary keys. Similarly, you're adding index. And then adding index is basically adding speed to these column. When you adding speed to these column, then when you have a select query, or when you're joining in a select query, or when you're filtering in the where clause or having clause, it gets speed up. It would get speed up because these indexed, it would get stored in another set of stack so that database can have quick access to these column, therefore speeding up the speed if you were querying, filtering, or query filtering or joining on these columns. Okay? Now, over-indexing means that in a table or in a database, if you almost make every single column or more than half of your columns all adding index to it, there's no limit how many index you can add. But the more you add to a certain point, past 50% of all the columns, then you essentially start losing that benefit of speeding up these query, because then every column became sort of all index, and then it kind of resulted in there's not really that much difference because all of them are now indexed. Okay, so that's what index is. You're adding an index to a column because you essentially found out that essentially these are the golden child columns that gets queried on, joined on, and filter on the most. And because of that, you know that these queries are often used and it has large data sets, so you want to speed up these query, right? So that's why you add an index to. Okay, now, why did I have to talk about another hidden primary key benefit that I didn't want to talk about earlier. This is where another benefit of primary key. Now, when you add index to a non-key columns or non-key columns, like Perl, you essentially added a column or you added an index to this column. The type of index we call non-clustered index. Okay, non-cluster index. And you can also say that you're essentially adding these columns into the group of non-cluster indexes. So either way, it's synonymous, but basically every non-key attribute, when I say non-key, is non-primary key, right? Not the non-foreign keys. Just the primary key itself is an exception. Primary keys, you do not need to add index to it because when you are creating a primary key or you're making a column of primary keys, it already by default a indexed. And specifically by default, it's the one and only clustered index of your table. Let me repeat what I just said. I summarize it. If you go ahead and try to add speed to queries by applying the indexing methodology, you can add index to a non-key column, or you can add index to non-key columns Perl, multiple columns. Those index that you added is what we call non-cluster index. That's the type of index. What those index does is that essentially it only have a special place storing the positions of this column so that it gets recognized and it gets pointed at quicker, speeding up your speed, your querying speed or filtering whatever speed. Separately, your primary key by default is already made a index when you're making it a primary key. However, the type of index is called clustered. Now, this cluster index is only going to apply to primary keys. So that's a special place and also the primary the benefit of primary key, because cluster index not only it would be speed up, just like how index normally does, but it also determine physical orders, right? It's the only index that has any say-so to the actual physical order of your data. So when you have a column initially that just say customer ID, before you make it into a primary keys, it can be sorted randomly. All right, it just sort of first in, first out, sure. Right? And that first in, first out, remember, is by the creation of that row. Now, when you created that row and the number that you give as the customer ID, it might not be in order, descending or ascending, right? Let's say before you make that into primary keys, the number is generated, automatically generated, a random number. So it may be 1 or 2 or whatever, but the 2 could have been inserted to the table before 1, right? But now I go ahead and make this customer ID a primary key, right? Because I didn't create a table with the primary keys. I go ahead and made that into primary key. Now, it now would get the benefit of all we talked about previously before with not set null, blah, blah, integrity, all that set null. no duplicates and all that. We get all that. Now we also learn it not only would also get an index, which means that when you're joining on this custom ID, since it's a permanent key, it will be fast. But also, the database is now going to go and order it, sort it sequentially. It's going to sort it. It's actually going to change the physical order so that it will be better queried because it's sorted. Okay, so that's index, and that's also what cluster and non-cluster are. Now look at the how you will create index to a normal index, non-cluster index to non-permanent key. You'll do create index on select table name and then the column. Okay? And then if you want to create index on two column at the same time, that means that this index applies, the speed up applies only when these two columns are used at the same time. This multi-column index creation is only applying the benefit when these multi-column are being used at the same time in your statement or your query. Okay, that's what the multi-column index created for. Okay, all right, let's move on. All right, so we are parking again now the integrity constraint and keys of a refreshment. And now we also went over the different type of indexing and what index are for. Now, we are going to come back and review plus looking at some new keywords, SQL keywords. And not only we're going to review it, I have made this table for you that you should definitely pay attention to and use this as a reference to look up on examples, either on W3 School or whatever during your homework or your project to practice it. So make sure that you know the full syntax on how to write it because they will show up on an exam. I don't know which one yet. I won't tell you which one will be, but this 10 of them is very high frequent visitor on your exam. Okay? You just need to know how to finish writing a accurate basic SQL query while you need to use any of these keywords. Now, the last time you saw this, I put together a table, but it's side by side showing what are the ones that are DML, what are the ones that are DDL. So you can go back to maybe lecture number 4, but we are like lecture number 6 now. So look at the left-hand side. Most of them are structure and design impacts. So most of them are DDLs. Okay? On the left-hand side, these keywords are DDLs because they are more structure and change on the design of a table or a schema, sorry. On the right-hand side, touches content constituent and the actual value. So they are likely categorized as DML. Okay, so let's look at first one. Each row defines what it's in terms of what it does. Okay, so when you have nothing at all in your database and you want to start creating the schema, such as table or view, you will use create, right? When you do create table, essentially it only create the house. There's no one living in that house yet. Until you move to the right side with the content and value, you're inserting value into the table. Okay? That's when you're moving people in, moving data into the table that you just used create statement to create. Okay, so you see create give you all the structural designs of your table. Think of it as the house. You're moving the constituent, which is the value, moving people in, use the insert into. Okay? Second line, copying. Now you have one table. Now I want to duplicate that table. I use create as when I want to duplicate the table just with its structure. So maybe I'm just making another empty table that looks and feels just like the first table without anybody living in there. But you know what I will get is when I create as, I'll get all the column exactly the same name, same data type. It's just a copycat. When I go to the right side and look at select into, now with select into, I am copy and pasting entire table A's, every single row and a value into a new table. Now, remember, I said copy and paste, not cut and paste. So it's not going to reduce whatsoever from the table A when you select into from table A to table B. It's not touching or removing any data from table A, but you're simply copying every constituent from table A to table B. That's when you use select into. Okay? You use create as when you just copycat the house. You use select into, you're copying and pasting the roommates, the tenants. Okay? Third line, alter and update. Alter is when you need to add the structure to the table or schema. You're adding a new column, you're adding a key, you're deleting a key. You need to say alter table and then followed by what you actually want to do, which is adding columns, deleting the key, or maybe changing the column's data type. All these doesn't touch the actual value that lives in there. Now, if you want to update, let's say, oh, someone bought the item and, you want to update the status from shipped to delivered, right? That's actual values that you're trying to change. You use update. Okay, because you're changing the value. Okay? Removing, let's go to number 4 line. Removing, you'll use drop or delete. Drop will wipe out the table from the planet of Earth. When you drop a table, it will wipe that table out. So in this case, it's a hybrid situation. It removes the structure that was housing the data. So in this case, it's kind of unique because you will also lose the data that was in this table. Or where else would those data be, right? Because you're dropping the table. You're deleting, removing, terminating the table, right? And so there's no house. So the contents will all be gone. So after drop, if you use the select, let's say drop table customer. After you run that successfully and you do a select start from customer, it will throw an error because in this case, it cannot even count how many rows there are because it cannot even find the table anymore. It's wipe out from the planet of Earth, right? So that will be the errors you get. Delete. When you say delete from a table, there's 2 ways to delete. One is delete all from or delete from, and then you choose where clause to select the rows that you want to delete. So you delete either rows by row, or you can do delete all, which is wiping out all the data in the table. Now, when you do delete, or when you do delete all, or when you do delete without having filter, both of which will wipe out all the data in this table, right? Delete all, or just delete, but without where clause. As I mentioned previous classes, that is a dangerous move when you have delete, but forget to put any where clause, right? Because it's going to wipe out all the data in there. However, say you did do that, and then after it ran delete all successfully, and you run a select star, in this case, again, the customer table. Delete all from customer or delete from customer and forgot the where clause. After these two says they ran successfully, do a select start from customer. You won't get an error. You will get 0 row returned in this case because it wipe out data's in there. But the house is still there. The table still exists. It just now have no value. Last but not least, informing. We all know what select does. It returns a result set of data. So get it out of the way. Remember last week, we talked about something very important that has to do with tops. The keyword top, the keyword limit, the keyword subset or offset. Those are for you to choose only certain amount of rows that you want in the query so that you don't overload and then blocking other people. Remember that we talked about that? Remember? And then you're doing a looping or whatever. Now, when you use the explain followed by a select query or explain followed by table, it essentially give you sort of a health analysis. Tells you how many rows there are in there, how speed or whatever. There's a lot of different explain and then followed by a certain subset of functions that you can explore. But what it does is give you essentially a health check or a preliminary informations, a balance sheet, if you will, a balance sheet, but not the actual returning the value, but give you the benefit, a balance sheet of the schema or of the query that you're about to run. So that's what explain does. Okay, so we don't have that much time because I actually went surprisingly slower than yesterday, but here are all the remaining deck is about all the example following these different keywords. So you need to really dive in and look at the syntax, what it does, and an example of it. And I highly recommend that you know, go ahead and practice. If you haven't already, probably I'm sure these already have been existed on W3 School already. But if you forget, and if you just want to practice some simple one, I'm not asking much, just highly recommended. I do want to mention here the insert into here because specifically relevant to your project. When you are at a phase where you have some database, when you have some code, and you have some front end, and then you want to do some not unit tests, not when you want to do some integration, you want to do some integration tests, okay, or when you want to do some UAT tests, okay. I don't know if you know what the difference between all these different tests, but I'm assuming you know what unit test is. But when you want to do UAT tests, meaning that you want to mimic the demo, you are likely want to make your demo or your UAT somewhat realistic, right? And when you say somewhat realistic, it's important for you to have something in your database. Okay, if you have all empty database to do a demo, it will look like you don't really have anything to show, right? It's hard to convey what your database can do dynamically if you have nothing, right? So, and then the more to a certain point, the merrier. If you have these dummy data to use in your database to make it look realistic. Now, obviously, we know in order to populate your data, using SQL is using insert into. Now, just so we know, insert into you can do as well with one row at a time. You can insert into data one row at a time. Or you can insert into a table with multiple rows at a time. Okay? Number one, that's the tip. Number two, we just learned you can do create as, insert into, select into. Over here, you might not immediately think of these usefulness, but just remember there's copying methodology over there. Keyword here as create as and select into, right? If you want duplicate tables, maybe you have some similar tables, or you want to duplicate the dummy data. Don't forget you have these, okay? That's second tip I want to give you. Third tip is that for just to make your demo look more realistic and you want to do quick and brute force of inserting data, so you can also potentially right click on your table and do an import CSV spreadsheet separated, comma separated, right? These are just way for you to occupying and getting some realistic, getting some dummy data to make your demo and make your code when you're demoing a lot more impactful. Okay, makes more sense, look more realistic. Okay, now. Then how do you actually create this data, right? You can thinking about, some dummy data as I always do, John Smith, Sheng Chen, whatever, and then, Sarah or, Rohan or whatever. But obviously, I'm not going to stop you from using AI. Obviously, you could always have AI creating, for the purpose of dummy data. I mean, even if you wanted to create insert into with multiple rows, go for it. Okay? Applying what is an ethically okay technology for the different situation. And this is totally something you are also good to consider. Now, you may also ask like, okay, these are all just making up data. What if, and this is for your project or maybe for your future project or hackathon, whatever. What if you really want to impress someone? And for some reason, by impress, I meant by having some data that is for analysis or whatever, and then you just really want to impress with real data, but public. That's another course we'll be talking about in data science. However, there are a site called data.gov, data.gov. It's a governmental website with all public data on companies, on user, on consensus, on city, towns, tax, or whatever, but it's public. It's not going to have any, I mean, it's government data, so you can take it with a grain of salt and then go realize what it is. But it is legal and free and public to use. How they get those data, it's from survey, from, tax return or whatever. But you can totally use that. And that is called data.gov. Okay. All right. And then don't forget to go and make sure you have clarity and understanding of each of these keywords in this matrix. And follow all of these follow the table. It has all these side by side. Last but not least, the one that wasn't in there. This is a side note. A lot of time, and we'll come back to more on authorizations or authentications. A lot of time, however, when you're coding, you may found yourself, or when you're in real life at your job, when you're querying, or you're in Create Enable, you may got an error, even though your SQL is totally correct, because you are not sure what rows you are. And by row, meaning each row in database may have different privilege on what you can use. And it can be as specific as to even select a single column. Relational database has have ability to restrict assets to a single cell. Okay, so these two, select user and select system user, give you a outlook on who you are currently logged in as and what system user is what rows and what IP address are you logging on as. Okay, so this is side note. All right, we have 6:37. Let's take a 3 minutes break real quick. And we just have a few more slides we need to go over to ensure next week we can finish everything we need to cover in lecture 7. So let's take 3 minutes break till 6:40. Thank you. Okay, let's continue. All right, so all right, we'll have to go a little faster, but that's okay. So the next sections we are first going to look at what we like to call relational database programming. Okay, so that means that we're going to begin talking about some more intermediate uh, relational database uh, features that's more than just single sentence querying or joining operations, etc. So, that's what we're going to go about. And then essentially at the end, uh, I'm not sure if it's covered by this package, but we will be covering a lot of things such as stored procedure, transactions, trigger, and etc. Right? Okay, so first and foremost, when we're talking about, when we get into another step, just similarly, we ought to face off in SQL, but somewhat similar to a programming language. And obviously, first we have already covered are the SQL statements, right? They are individual one line to multiple line with one semicolon. They're SQL statements with keywords, right? So those are similar to like a one line constructor or comparators when you think about like or like single line functions, well, whatnot, or expressions, okay, when you're thinking about Python, Java, etc., right? So that we are very familiar with that, and then obviously look into DML, DDL, which we just talked about, very important things, uh, as always, and those are SQL statements. Now, SQL variables, obviously, we cannot have no variables when we are talking something about programming, right? Variables are the most basic minimum unit, right? That you either are setting a value to or you instantiate it and then use that as a temporary measure of storing certain value or data within a function or outside a function, right? That's what variables are. And then here is how you would declare a variable by saying declare with its name following an @ sign and the data type, right? And for example, over here, you're setting almost like you're setting an object here in coding in Python. You set at the name total count in here to select count star from orders. So you're storing count from the orders in total counts. Okay. Now the at total count here also, as I mentioned previous slide, could be storing a temporary table. Okay? It could be storing a temporary table. You can store a table as a temporary table using the @ sign with the name by assigning using set keyword, assigning it to a variable. Okay, that is how you would continue calling that variable within later on, whether it's as, select from that variable so that you can process the data or querying whatever, just like a normal table, but that's how the temporary table works. Now there's parameters. Obviously, we know parameters are, right? Parameters are either inputs or outputs, okay, of a function, right? So as you can see here, a procedure is a function, okay, for SQL query, for SQL. All right, and so in this case, you want to get the user information of the user with this input, with the value of this input, which is the user ID. So basically, the end user would provide the user ID, and then you would take in that user ID as a parameter and run whatever query, right? In this case, get user, and then run the query, so on and so forth. Okay. Now, very bottom is a reminder on how to declare and set your variables. Now, the first thing that we are going to cover is the conditionals, right? How do we not cover conditional if we're talking about programming, right? Why? Because unless you have conditionals, and when I mention conditional is saying that if we have a condition, and that condition could be a crossroad, meaning that there is some certain decision you can make. And that's simply each decision could be option A, option B, option C, right? Without a conditional feature in SQL, you would have to rely on external code to process these if statement or whatever statement, conditional statement. And then once it's done, then you send a call to process the SQL that you want to run, right? If there was no SQL condition features, right? But now we're just saying that there are a programming functionality in SQL that allow you to make evaluations on a condition. And if it falls under true, the database is going to run the desirable statement in this way. If it's false, then it will continue to look at the second condition, whether or not it falls into true or false of that condition, and make another, following actions accordingly, right? So that's what the condition simply said. It's the if and
Professor,
else. Yeah.
I just want to confirm, are you sharing like new slides or because I just see references still. Or are you going over?
Yeah, I'm sharing new slides.
I just see
Oh,
references.
really?
Yeah.
It is showing screen though on my end. I don't understand why.
No, it doesn't show it shows the references slides.
Oh,
Yeah, that's
how about now?
the screen sharing.
How's now?
No, still the same thing.
What?
Oh,
How about now?
I think now it's good.
Oh,
Let's go
okay.
from there.
Wow. That oh, I made a crucial mistake. Sorry. Damn, wasting so much time. Okay, so let me just complete so that you can catch up. All right, so that was the first slide that I was talking about the statement variables versus parameter, right? We have some for the programming, okay? And then we're just talking about introductions conditional. Thank God, it's just 2 slides. Okay. All right, so let's jump in here. Let's take a look at the first more entry-level conditionals, which is the case statements. Okay? We have case in Java and Python, so it shouldn't be too unfamiliar for you. So case is a graceful way to evaluate different conditions by using multiple options following the word when. Okay, so you can create as many conditions as you want by having the condition followed by the keyword when. And essentially you're getting multiple conditions that way. And then you add the word after your conditions or whatever you're evaluating to with the then. Finally, following the actions you want it to take accordingly. Okay, so simply put, case when and then until you are closing your case, meaning that you don't have any more conditions that you want it to behave in a certain way anymore. You will put the keyword end to it, right? That's how you close out the case, making sure you have, if you have a case start, you have end to close it with. Now, obviously, we know what else does here. So else would just take in every other case and scenario that you did not mention prior to that. Okay, so you have all tens of conditions and you have an edge case. If you have an else action, it falls under that. So simple, not too big, not too much of a big deal. Now, in this example, the case is being applied as a display of a column, okay, in your result set with the select query. So in this case, you want to show that if certain order number has the order number itself has certain order has a high quantity of items in there, right? That's what you want to see. But instead of the actual number of items, you want to only get 3 type of behavior or 3 type of results, which is high, medium, and low. If it's more than 100, it's high. If it's lower than 50, medium, otherwise low. I'm sorry, higher than 50, between 50 to 99, then it's medium. Between 50 to 100, then everything's low. Okay, this is from the result set, as you can see, is returning high, medium, and low in the quantity category. Now, you can also have it in, this is another example again with the columns, so let's just skip that. This is an example when you're showing something directly to the column, but you're applying the case conditional in where. Okay, you can also do that. Now we learned that you can put it in select and you can put it in where clause. Now, in this case, is that if you're evaluating if the marital status in your table, as long as it's S, I'm assuming it means single, then return 1. Otherwise, return 0. But look at the case, ends in front of the equal sign to 1. That means that the value here is essentially within the where clause, but comparing the value with 1, right? So that means that only when it's single, it's going to be evaluated to true in the where clause. In other words, returning the rows only when marital status is S. Okay? So that's just an example in case, but in a very, I guess, strenuous ways to explain. All right? So that's just marital status, which is an example of case applying in your where clause. Last but not least, you can also choose with a condition the order how you want to, the order of columns, how you want to order your table by or your return result set by. And this is how you would do in order by. Remember, order by is sorting, okay? So in this case, if the city is null, then sort by country, okay? Otherwise, sort by the city, okay? Now, the next one, slightly more advanced, is the if and else, which is no stranger to any of you. On the nutshell, the difference as far as syntax wise is that it's case when followed by then. When you use if, it's just if then. However, there's else if and also the catch-all with else. Okay, and to be very detailed and then very careful, you still need to end your conditionals. And in this case, for the if, it's not just the end, it's and if. Okay, it's just settle in and let you guys digest a little bit the difference between the syntax in color code. Okay, so it's if then, else if then, okay, and then finally, when you're closing the if conditionals, it's end if, not end. Let's look at an example. So this is not itself a statement, right? This is actual function itself. It looks like a procedural coding in here, right? Now, this also give you a preview that the if statements are a lot more flexible. It's not used as restricted as case, only in statements. Even though if can be used in statements as well, it's a lot of time using in actual procedures, which we earlier mentioned. A procedure means like a function within SQL, right? Now, before we learn a lot into the procedure, which we'll learn not today, we'll talk about store procedure next class, but that's just as a prelude. Look at this example, right? Supposedly, P operator was a variable that we had taken from a parameter, right? A parameter from a store procedure or whatever, right? This is trying to evaluate that the parameter that was taken in, whether or not it's a smaller sign or larger sign, okay? And based on that, you're due either a comparison in your where clause larger or smaller. As simple as that. Okay? You don't even need to have an else in here to catch all, right? That's totally fine, just like how you're normally programming. Else is optional. You can do if and else if, else is optional. Okay? Now, here is just kind of for your dictionary reference. Here are all the operand that you can often see when you're doing some conditional evaluation, okay? It's just these operand that we oftenly use in where clause, right? But rather than in where clause, we are applying that in your if sort of if statements in the conditionals, right? So nothing to worry about. Use this as your sort of reference and dictionary. Loops. Okay, there is loops as well in SQL. However, it's only limited in while loop. Okay? By saying that, it should already cover and we can flip the page, but just to be sure, we're going to go over what a loop would look like as far as syntax wise. But before that, assuming all of you know, a loop is basically a type of procedure, building procedure of a programming language where it evaluate the condition and enter a circle where the circle contain one to multiple instructions. When it finishes all the instructions, it will checks back whether or not the initial condition has been validated or is still within the initial condition. If it validated the initial condition, then your procedure will jump outside of the circle to go execute the next step. Say if it's still within the condition original set, then it will continue running again within the circle. So that's what the loop is, okay? Now, the syntax is simple as while and give another expressions of conditionals. Then you add a do, and then whichever statements, one to many statements, followed by and while. So between do and, that is where the circles are. Okay? So let's see. Really quickly overviewing on this, okay? Use together, look at it with me because this is just a practice. I'm sure that it's not hard for you guys to understand, but let's go over it so that you guys have the clarity together. This, in a nutshell, also is a symbol of a store procedure, which we'll cover later on. But let's use this as a store as an example. So this procedure is called while loop procedure. So within the begin to the end, the first step is declaring x as an integer, declaring str as a varchar, which is equivalent to programming string, and set the initial value to x to 1, string to an empty string. So while x smaller than 5, because initially x is only equal to 1, so this will be met the first time, you entering the do, which is the loop. Okay, so then the loop will include two statements. One is the set string, one is the set x, right? And then so every time it will add 1 to x. So the value every time it's in this while loop is adding 1. Okay, so basically concat, as we learned earlier, that it's combining, joining the text, right? Adding whatever that was in the string, which originally is what's it called? Empty string with the value of x, and give it a single quote, another single quote. Okay, And every time that will set the string to that. And because the string str is outside of while loops, so that when it run again, it would remember the latter expressions, right? So the second time when you hit n, it will come back to the do again because it will evaluate whether x is smaller than 5 because now it's at 2, so it will still be true and then go into loop again until it will run to up to 5. And now we end up getting is some empty one and then quote. It will be like four single quote and then one single quote, two single quote, three single quote, all the way to 5. So basically something like that, as you can kind of figure it out. Now, an infinity loop is when you don't have anything such as this evaluations or this counter, such as set x equal to x plus 1, so that this condition will become something that never made it to false, right? So never gets validated, and you end up finding yourself stuck within the loop. That's when the infinity loops happens. And then it just, when it's an infinity loop and then it ran, it just go never ending. And it just end up have memory loss and I guess times out, errored out. Finally, we are at transaction, but we're not going to get into detailed transactions. I am just going to bring this transaction back as a refreshment and we'll cover the details about it next week, okay? Now, to refreshen our memory, this class has said over and over again that the relational database is also known as SQL database, is also known as relational database, as well as transactional database. Or if you want, it's a no-NoSQL database, right? So opposite of a NoSQL. Okay, so transactional database, and the reason that it's also known as transactional database is exactly here. Because it has this locking of transaction and the rollback or committing functionality and a feature, which kind of back to similarly what we have the integrity and constraint to ensure, given that there's these transactions exist by default in relational database, which is transaction is a cloud of one to many lines of procedure or function or expression, a group of them or a call of them. And while they are inside of a transaction, they have by default ability blessed by relational database that they could be all or nothing. They could all fail and you can roll it back, or fail at one point and you can roll it back like nothing happens, all or nothing. Okay? Or you can have it after they're all successfully passed and commit and blocking any other later on changes or later on anything trying to rolling it back because there's some system failure. Transaction will protect that when you commit all these codes as one, it's all or nothing. And that's the constraint transaction had, as well as the integrity had, that made relational database, also known as transactional database, however, also known as transactional database, and also famously with the ACID property over here, again, atomicity for the A, consistency for the C, isolation for the I, durability for the D, ACID. Okay? I'm just gonna go over what they means again. All or nothing for atomicity, we covered that before. Consistency maintain database state, meaning that if it has been committed, the transaction has been committed, the impact, the changes has been made and done and committed to the database, you cannot have a dirty or outdated result set when you are querying them. It will stay consistent and it's not going to give you any time of a non-finished product like a NoSQL would do, but I'm not bashing NoSQL. I'm saying that the NoSQL would rather give you a intermediate result so that you are not waiting on the results because they prioritize availability. NoSQL prioritize availability, where SQL prioritize consistency. It return result that is to the most current accurate value only to you. They're not going to give you a midway update. Isolation meaning that if I have a transaction happening on certain table, it's going to lock those table involved until the transactions are committed or done so that other places cannot, again, cannot have a dirty read or raise conditions, or it cannot simultaneously adding and therefore became some race condition or like mixed up different results at the same time. Okay. Durability means again, go back to the rollback and commit, meaning that if it's committed, it will stay permanent. If it's rollback, it's not going to all of a sudden show something in the middle. It's all or nothing. Okay, that's what durability said. Finally, it just the first word of each of these feature became ACID, and that is the core competency of relational database. It as versus NoSQL is interestingly base, BASE, right? Chemically opposite to ACID, but also in database management system. BASE stands for, once again, I've mentioned this before, BASE stands for basically always available. Okay, as you can see, the available and always, right? So they prioritize, NoSQL prioritize on availability, meaning to send you something on its way to the future state. And then eventually, after a couple minutes or a couple seconds even, today's database, modern database, with NoSQL database, it would be eventually getting the accurate final stage. But they will prioritize showing you something, some of the update, rather than you waiting on the accurate result. Okay? And we are going to show you what transaction look like and the syntax of it starting next week. All right. So other than that, you guys are free to leave unless you have any question. You can stay behind, and I'll see you in person next Tuesday.
So I got
Okay,
like
thank you,
two
Joseph.
questions.
Yeah, sure. Hello.
Yeah, I'm sorry. So I had a question about the homework, I think homework 7.
Uh-huh.
And in question 1, you say enter the Git classroom link to the PDF or PNG of question 1. So I was kind of confused on what you meant by that. And also, my second question is like, so I tried to use the draw SQL like you suggested to kind of draw the tables and stuff.
Mm-hmm.
And when I'm trying to establish the relationship between tables, it doesn't have the many to many relationship.
I know. No, well, that's fine.
Okay,
You don't need to have many-to-many relationship for 2NF.
okay,
It's gonna be fine. Draw SQL, I've used it many times. It's eventually will be fine, especially for 2NF. It will be okay.
okay.
Exactly. Yeah. You don't need a many-to-many to You don't need many-to-many, right? I remember I said you just go back to the lecture notes. You don't need many-to-many in 2NF. It's theoretically many-to-many shouldn't exist in 2NF table. You need a transit table anyways. Anyways, the first question is what GitHub? I don't have that on hands, but I'm pretty sure I just meant that when you draw your diagram, right? You can, if you're hand drawing it or if you're using some program that doesn't have a URL to that diagram, like public URL to the diagram that you draw, then you can upload the diagram to Git class, just like how you submit all your evidence previously, and then
Oh,
share the URL. But if you're using DrawSQL, you just have to make sure that the picture, that the diagram you draw is public. And then you should get a free URL as well. You can also use that when you submit.
I can use the URL where I draw the actual the table and the
Wait, can
e
you repeat what you said? You said, are you saying, am I hearing you said you can use the URL from DrawSQL?
yes, can I?
Yes, but right, yes, you can, as long as it's the actual link to your diagram. You cannot send me www.drawsql.com.
No, of course, I understand that.
Right. And you have to make sure because you can make your diagram private or public. Just make sure
This is public.
that it's public. So when I click on it, I can access it.
Okay, that makes sense.
That's all. Yeah, you can do that, or I mean, since you're using DrawSQL, that's just simple. But if you're not, I mean, for some other people, if it's drawing by hand or you're drawing the table with pens and paper, then you take a picture, check it into Git class like every other homework, and then send me the URL.
All right, thank you.
Okay? All right. Other questions? Anybody other questions?